Yes, so our chapter for this class is the first demo class of physics is kinematics. So kinematics is basically the study of motion. We analyze motion and we model the behavior of moving particles. Any particle, whether it is at rest, moving with a constant speed or with a varying speed, when speed varies we call it acceleration. So all these kinds of types of motion, we analyze these types in this chapter. And the important thing to note about till now is that for this chapter, till now, we're ignoring the effects of any force. Ignoring any effect of force. We'll study in the next chapter called dynamics. So we studied in that chapter forces. Okay, so in this chapter we are only concerned with speed, velocity and acceleration and the respective time graphs, distance time graph and a speed time graph. Okay, so basically primarily concerned with these things. No force, no action of force required, equilibrium or that kind of thing. So that's for the next chapter. So that was introduction. So now we'll move on. Okay, so now coming, we first have to distinguish between the types of quantities. We have generally two types of quantities. Can branch them into two. The first one is called a scalar quantity. The second one is a vector quantity. A scalar quantity has only magnitude, while a vector quantity has magnitude plus an associated direction. Okay, and for its description, magnitude for its description for a scalar quantity description, and vector magnitude plus direction for its description, so that the quantity is described completely. As an example, normally you would take a scalar to be distance or speed. Distance or speed are considered to be scalar quantities or speed. So let's say we travel a distance of 5 meters. We don't associate any direction with that. Okay, we just say 5 meters. While coming to the vector quantities, we as an example take displacement or velocity. And interestingly, the units of distance and displacement are same, and the units of speed and velocity are same. But the thing that makes them different is that one has magnitude only and the other has direction with the magnitude, so velocity. So we cannot now say that 5 meters displacement. We have to specify that 5 meter where, in which direction the object travels. So we have 4 directions: north, east, south and west. So we can say 5 meter towards the east. So I have to specify east with the quantity. Okay, so that's displacement. That magnitude, this magnitude and the direction both needed for the quantity's description. Okay, description. To describe any quantity completely, how we describe any quantity completely. Okay, so there's a general distinction between scalar and vector quantities. That's very important. That will carry throughout your physics course, your O-level physics course. Okay, so other examples I can give. For scalar, you have normally work, pressure, or you could say power, and for vector, acceleration, force, momentum. These are branched in vectors. Okay, so that was an important distinction before we jump into the real things. Okay, so we move on. That should be pretty clear now. So now coming to the our basic discussion. So what's distance? Distance is generally defined as a scalar. So we now have no need for its direction. Simply the length. This is an important definition. It can come in your exam. This is the length between any two points. So let's say we'll have an example afterwards before we define the displacement. So distance is called as the length between any 2 points. Okay, so now displacement, and we can then have a contrast between the two to make things clearer. Displacement is defined as the shortest distance. This is a keyword. Shortest distance between 2 points, plus it is a vector. So you now know if it is a vector, it will definitely have a direction associated with the magnitude. Okay, so displacement is the shortest distance between 2 points. Now to have a simple comparison, a contrast between the two, I provide you an example. Okay, so now we will come upon an example. Okay, so let's say there are 2 points A and B. A simple example. 2 points A and B. This is point A and this is, let's say, point B. We now have to travel between the 2 points. Okay, so let's say there's a road between the 2 points, and that road goes winding this path. Okay, there is a road. Make a road. Okay, made a road so you can relate it easily to the real life. Okay, so we made a road. Now let's say a car travels. So this is a car. The car travels to the road. Okay, assume that there are mountains. Here are mountains across the road. You cannot travel here. Okay, large mountains, and like you've ever gone in hilly areas. So the car moves on from A to B. So all this direction the car moves. This will be defined as the car's distance. distance from A to B the car travels. Okay, all the path that it travels, that will be its distance. Now we first define the displacement as the shortest distance between 2 points. So now the shortest distance between the 2 points will obviously be a straight line. But if we make a straight line between the 2 points, that will be termed as the displacement. How can we cover the displacement? In the real life, let's say we have a helicopter. So it can travel straight from point A to B. No winding around path, no zigzag, no nothing. Okay, so it's easy for the helicopter to travel straight from A to B. Now when it travels straight from A to B, this will be called as the displacement from A to B. Displacement from A to B. And now respectively, we can also associate a direction also of this displacement. If we use bearings, you will study bearings in your further after your O level math. So if you study bearings, we can also zoom bearing an angle with the 0 degrees we start. So we can also give a direction. Let's say this is a 90, and this is plus, let's say 30. So we can say it is a bearing of 120 degrees. So this will be your, and let's say it travels 8 meter. So 8 meter and 120 degrees will be your displacement. While let's say the distance will be obviously long. Okay, so let's say the distance will be covers 20 meter. 20 meter distance covered, and displacement as the shortest distance, so it will be obviously less than the distance. Okay, this simple contrast, while distance and displacement can also be same in situations where, let's say, a point A to point B, there goes a straight road, so the displacement will be equal to distance. Okay, that situation can also occur. Okay, and another situation can occur where the object has traveled some distance but not any displacement. So when does that happen? Let's see. So as vector quantities have direction, we can assume same signs for in the same direction and opposite sign in the different direction. Okay, so let's say in the beginning, let's say an object moves 5 meter. Let's say again zoom points A and B, 5 meter towards the right. This will be termed as positive 5 meter displacement. Okay, and it then also returns from B to A, then the same point. So we had taken sign positive, right direction as positive, left direction as negative. So when we will add these two, plus 5 and minus 5 will get you simply 0 displacement. Well, the distance is covered. 5, you add 5 plus 5, add as distance has no direction, hence no sign with attached to it. So distance will be 5 plus 5 is equal to 10 meter. That will be your distance. And 0 meter will be your displacement. Okay. So I can generalize now the statement. Okay, you will deal with the direction and the signs later also. Okay, so there is no worry about it. In this chapter we just have a preliminary discussion. Okay, a beginning discussion. So you will study detail in the forces chapter. Now to just generalize in our context, generalize if the starting, I say the statement, if the starting and ending points of the journey, if the starting and ending points of a journey are same as in the previous example. You see the car returned to the object returned to the same point A. Okay, are same, the displacement will be 0. This displacement will be 0. Okay, that's simple point. If you go on a journey, let's say you begin from your house, you go to the, let's say, a park, you return from the park, so your total displacement will be 0 as the shortest distance between your point of start and your point of end is 0. You began from the same place, you got up in the end at the same place, so you traveled your distance to another place to any other place was 0 because you ended at the same place. That's simple statement. Okay, so that our discussion of distance and displacement here is completed. So in the next video we'll discuss speed. We'll begin about speed, velocity and acceleration.